Imagine a world where the sky is never blue, where instead of rain, torrents of molten glass cascade from the clouds, and temperatures on the surface can vaporize any metal within seconds. This is not science fiction. This is a real planet. And it exists right now, somewhere in the abyss of the universe, burning in the embrace of its star. We live on a remarkable planet. Earth is a world of moderate climates, blue oceans, and gentle rains that nourish forests and rivers. When we hear the word rain, something familiar comes to mind, even something comforting. Droplets on a window pane, the smell of wet earth, gray clouds drifting along the horizon. But the universe is a cruel and ruthless architect. It knows how to build worlds that shatter every assumption we have about reality. And one such world, the exoplanet WASP-76b, left scientists across the globe genuinely speechless. This planet lies roughly 630 light-years away from us. 630 light-years. Light, traveling at nearly 300,000 kilometers per second, takes 630 years to reach WASP-76b. When the photons reflected from its scorched surface first began their journey toward us, Columbus hadn't yet set sail. Leonardo da Vinci was just beginning to sketch his earliest masterpieces, and Europe was in the early bloom of the Renaissance. And now, all these centuries later, the light from this monstrous planet has finally reached our telescopes and told us something we never expected to hear. WASP-76b is what astronomers call a hot Jupiter, a class of planets comparable in size to our own gas giant, yet orbiting so close to their star that a single revolution takes less than 2 Earth days, just over 36 hours. And the planet has already completed a full orbit. For comparison, Earth takes 365 days to do the same. This means WASP-76b sits at a catastrophically close distance from its star, roughly 12 times closer than Mercury is to our Sun. And Mercury, it should be noted, is already considered a hellishly scorched world, where surface temperatures reach 430 degrees Celsius. But what happens to a planet that is 12 times closer to its star than Mercury is to the Sun? Something unimaginable. The dayside of WASP-76b is heated to between 2,400 and 2,500 degrees Celsius. This isn't just very hot. At these temperatures, iron, the solid metal we use to build bridges, ships, and skyscrapers, doesn't simply melt, it evaporates. It becomes gas. The entire atmosphere on the dayside of this planet is literally saturated with vapors of iron, nickel, calcium, and other metals that here on Earth we think of as unshakably solid. Up there, in the skies of WASP-76b, metallic vapors rise, are carried by ferocious atmospheric winds to the planet's nightside. And there, where it is slightly cooler, they condense. They fall as rain. But this is not water. It is molten metal, raining down from the heavens. And now, the glass. Because this is precisely what made WASP-76b truly legendary in the scientific community. Enormous quantities of silicon oxide were detected in this planet's atmosphere, a compound that, among other things, is the primary ingredient in ordinary glass. At the extreme temperatures of the dayside, this material exists as a gas, but as those scorching atmospheric currents carry it over to the nightside, where temperatures drop, though they remain crushingly high by any earthly standard, the silicon oxide begins to condense. It gathers into tiny droplets, and those droplets fall, rain made of glass. Not a metaphor, not poetic exaggeration, a literal, physical, real rain of molten glass, pouring down on the nightside of one of the most extreme planets humanity has ever encountered. How did scientists even manage to detect this? After all, WASP-76b is 630 light-years away. No telescope can simply photograph its surface and say, "Look, it's raining there." All of this became possible through a technique called transmission spectroscopy. When a planet passes in front of its star's disk, some of the starlight filters through the planet's atmosphere. Different chemical elements and compounds absorb light at very specific wavelengths. These are their unique fingerprints. By analyzing which wavelengths were absorbed, scientists can literally read the chemical composition of a distant atmosphere without ever visiting it. And it was precisely through this method, using the espresso instrument mounted on the very large telescope at the European Southern Observatory in Chile, that this stunning discovery was made. Astronomers noticed something strange. The iron signal was significantly stronger on one side of the planet than on the other. That was the key. Iron evaporates on the dayside, is carried across by the wind, and condenses on the night side. A cycle of metal, in place of the water cycle we know so well. But let's pause for a moment and truly feel the scale of what is happening. Imagine you somehow found yourself inside a safe capsule, hovering high above the night side of WASP-76b. All around you, absolute darkness, because this side of the planet never sees its star. WASP-76b is tidally locked. Just as our moon always faces Earth with the same side, this planet always turns the same face toward its star. The night side is eternal night, eternal darkness, and in that darkness, from above, with a roar and a hiss, rain comes pouring down on you. But instead of cool water droplets, searing droplets of molten glass and metal, each one capable of burning through anything. The sky here is not gray or overcast. It is crimson, flickering, saturated with heat that bleeds across from the dayside through monstrous atmospheric currents. The winds on this planet reach speeds impossible to imagine on Earth, more than 10,000 kilometers per hour. That is 10 times faster than the most powerful hurricane ever recorded on our planet. The discovery made by a team of astronomers led by David Ehrenreich in 2020 stunned the scientific community. But the story of WASP-76b didn't end there. In the years that followed, more advanced instruments, including the James Webb Space Telescope, launched in late 2021, and arguably the most powerful eye humanity has ever turned toward the cosmos, allowed scientists to deepen their understanding of this world. It turned out the atmosphere of WASP-76b is even richer and more complex than it first appeared. Traces of water, or rather, water vapor existing under such conditions, are present there. There are signs of carbon dioxide, and, perhaps most intriguingly, data from the James Webb Space Telescope revealed possible traces of sulfur sulfide. This sulfur compound, under certain conditions, can be associated with chemical processes of potential astrobiological interest, though on WASP-76b, of course, there is absolutely no question of life. It is simply yet another testament to how chemically complex the atmospheres of exoplanets can be. How do worlds like this form in the first place? That's a fair question, one that anyone encounters when first hearing about hot Jupiters. By every law of planetary physics, a gas giant should not be sitting so close to its star. In our own solar system, the gas giants, Jupiter, Saturn, Uranus, and Neptune, formed far from the Sun, beyond what is known as the snow line, the region cold enough for lightweight gases and ices to condense and participate in building large planets. So why did WASP-76b end up so close to its star? The answer lies in planetary migration. According to current understanding, hot Jupiters form in exactly the same way, far from the star, in the cold outer regions of a young planetary system. But then, driven by gravitational interactions with the gas and dust disk from which the system is born, or with other planets, they begin to move slowly but steadily inward. This journey can take millions of years. Gradually, the planet loses orbital momentum and creeps ever closer to the star. Once it draws close enough, the star's gravity locks it into tidal captivity. The planet stops rotating independently and begins to keep the same face permanently turned toward the star. That is exactly what happened to WASP-76b, and it is exactly what created that wild, apocalyptic contrast between its eternally blazing dayside and its eternally dark nightside, drenched in glass rain. And here is the question that has surely crossed many of your minds. Could a planet like this exist closer to Earth? Could somewhere in our galaxy, right next door to the solar system, a world just as nightmarish be hiding? The answer is yes. Hot Jupiters are not rare in the universe. Astronomers have already discovered several hundred of them, and there is every reason to believe the true number is far greater. We simply haven't found them yet. The nearest confirmed hot Jupiter, the planet 51 Pegasi b, sometimes called Dimidium, lies just 50 light-years away from us. That is, of course, still a colossal distance by any human measure, but on the scale of the universe, it is practically next door. This planet was discovered in 1995 and became the first hot Jupiter ever found orbiting a sun-like star. The discovery turned planetary science upside down. It became clear that our solar system is far from the only possible architecture for a planetary system. The universe builds worlds according to all manner of blueprints, some of them utterly wild. But here is what matters. Our solar system appears to be something of a rarity, a place where gas giants stayed where they were supposed to be, far from the central star. And this, quite possibly, was one of the key conditions that allowed life to arise on Earth. Jupiter, sitting on its distant orbit, acts as a giant gravitational shield. It draws in many of the asteroids and comets that would otherwise bombard the inner planets, including Earth, with a frequency incompatible with the development of complex life. If our Jupiter had once migrated inward and become a hot Jupiter, the history of Earth would have been entirely different. Most likely, there would simply be no Earth at all. That makes looking at WASP-76b feel like something more than curiosity. This isn't just a distant exotic hell. It is a mirror, a warped and terrifying mirror, reflecting an alternate fate that any planetary system might have suffered. The universe is full of such mirrors, and each one tells us something important about how fragile and extraordinary our own world truly is. The science of exoplanets is advancing at breathtaking speed. Just 30 years ago, we didn't know of a single planet beyond the solar system, not one. Today, the catalog of confirmed exoplanets numbers more than 5,000, and this is only the beginning. The James Webb Space Telescope is granting us the ability to study the atmospheres of these worlds with a precision that once belonged purely to science fiction. We are learning to read the chemical signatures of distant planets, to detect traces of water, carbon dioxide, methane, substances that on Earth are bound up with life itself. We have not yet found a single planet that is definitively habitable, but we have only just begun to truly look. WASP-76b is not an anomaly or a curiosity. It is a message about how diverse, how extraordinary, how merciless, and at the same time how breathtakingly beautiful the space beyond our tiny blue world can be. Out there, in the darkness between the stars, there are worlds where glass rains from the sky, worlds where metal boils in the atmosphere, worlds where there is not the faintest chance of life as we know it. And yet, there exists a kind of wild, apocalyptic beauty, all their own. The universe is vast. It is billions of years older than us, and it is full of secrets we are only beginning to unravel. Every new discovery is not just a line in a scientific paper. It is a reminder of how small and how precious our world is, of how rarely, perhaps, the darkness of this infinite cosmos holds what we have here. A soft rain, green grass, a blue sky. Cherish that sky. Look up at it more often, and remember, somewhere out there, 630 light-years away, another sky, crimson and blazing, is raining drops of molten glass onto a dead and silent world. And somehow, that makes our sky more precious than ever. If this video made you stop, even for a moment, and look at the universe with new eyes, hit that like button. It's a small thing, but it helps this channel grow and allows us to keep bringing you the most astonishing mysteries the cosmos has to offer. And tell us in the comments, which planet, out of everything we know, strikes you as the most terrifying or the most beautiful? We genuinely want to know what you think. Stay with us, and until we meet again among the stars.